with the presentation. Let me start sharing. Amir, I would like you to confirm that it's working and you can see my screen.
Yes, go ahead.
Okay. So, hi everyone. My name is Anas Lila. I'm Egyptian, 100%. I'm a lecturer and researcher in architecture and computational design in architecture too. Today is basically it is an academic in a way, but it's not that academic. It's just a debate between me and myself about those two words, digitizing and placemaking, or the quantitative and the qualitative aspects of our built environment in general. And the question mark is there for all of us, is like, is it possible? Is digitizing placemaking can make it something different? This image is something to remind us about how we see buildings really, because usually we have these photos when it comes to placemaking. In one of the posters for the series, you'll find another photo with moving people, but the buildings are there. But actually, we are architects. We deal with this. We deal with the physical aspect of buildings. So if I choose another name for this presentation, it's going to be like a series of disappointments, or like encyclopedia of failures, or something like that, just to talk about how much I was hoping in certain stuff, and then I couldn't achieve, or maybe some dreams that I followed, and then I diverted that to other things. So through the presentation, we will see my thinking development, and when did I start my career, and where am I now, and how can digital aspects and computation methods like be injected within that. So to start with, I started working just after graduation in a company called Zuhair Faiz in Saudi Arabia. And I was working with healthcare facilities. I was part of the design team of King Faisal University. I was lucky enough to be part of those who deal with large projects just after graduation. And I was fascinated with the rendering, the design aspects of it. And my role in this project was basically taking care of the core and taking care of the lighting and studying sustainability aspects. Back then, it was something we call, like, there was something called LEED, and it was new. And we talk to the client about it, and we talk about the lighting, about the HVAC, how can we reduce the HVAC in the building, and how can we reiterate the air within the atrium, stuff like that. So this was the spark of hope about sustainability and how we can deal with the buildings in a different way, rather than just renderings and geometries and these fancy cores that you can see here in the screen. But then years after, jump onwards, you see the building don't have these fancy aspects anymore. It's just, again, another building. And actually the client diverted a bit from the sustainability thing. Important to mention that this building have got an award for best healthcare facilities in Middle East at that era of the design. But then I don't know about the construction, but these photos are from Google. So this fancy core is not there anymore. It's just a simple one. So there is some sort of a clash. There is some sort of divergence between what we hope for in the office and what's actually on the reality. Then during that, I was doing my master's in Egypt, and again, fascinated with these names, Priam and LEED, and how shiny it was. I took it into application, and I just tried to solve that clash about why we don't apply these things in our region or in our practice. And I did an analysis of the energy points of those two codes or rating systems into healthcare facility in Egypt. And I saw a very large gap, and I saw that it's not really happening within the code, within the application, within the practice of building. There is a gap, there is something missing in applying, as we call, sustainability or energy efficiency or whatever into our practice, especially in Egypt. That's where I come from. Then there is this guy, a very fancy architect, telling us about that. It's life spaces, then buildings. The other way around never works, never works. Okay, this was again a shiny aspect, a beam of light that, ooh, okay, I need to follow this. So how's life in Egypt? How's life in the practice? How we need to let out the office back then and then go out and see how's life. That's life. This is how life is in Egypt. It's like when you go into a slum or a building out the a constructed building without the council or whatever admission from the government there is, and we have statistics that says like more than 70% of buildings in Egypt or construction in Egypt is actually outside of the governance, which we call slums or call it whatever you name. This is actually somewhere called Azbit al-Matar in Alexandria. Again, this is another shock to me that to see that this is an Alexandria. I mean, Alexandria to us is fancy, is the Corniche, is the seafront and how fancy it is. And then just a couple of miles away, you see this. I had a workshop back then with the AA trying to find solutions for this district. But I learned a lot after years and years of finishing this. We finished it in like a month or 3 months or something. Then we did the survey. We did the whole social aspect of talking to people, trying to talk to the council or the governorate, and we found out back then that yeah, okay, actually the older scholars in the workshop they knew, but they let us do it. But anyway, it gave us another hope. But then it gave us contact. It gave us the true meaning of life. The people there, we say life people, then buildings. Okay, the people there are actually living and they're happy and they're actually smart and they are developed and they are way advanced than what we think of their life. They are adapting. You can find a pool party in the street with just a very primitive shade, and they are really smart. They are actually faster than all of our perceptions. They are bigger than all the stakeholders' capabilities. You cannot adapt all these buildings and do the building physics analyses for these curtains and see which one provides privacy and which one provides shelter from the sun. It's there, you see it, and they did it for different reasons, but it's just they are smart and they are way faster than we think of. So what's the other way then? So he said like never, the other way never works. So the other way for me was Patrick Schumacher's autopsy of architecture. This is a very important book for whoever wants to follow the lead of Patrick and how he is actually presenting his work and his studios in AA. He see urban as a test field. He tries to do biomimicry. We'll talk about biomimicry later, but he's trying to do biomimicry into geometries and find the form first, and then try to adapt this form into the nature of the context that he's designing in. You see different nature of urban, and back then we have been taught in the school that okay, don't look at this, like turn the blind eye to Zaha Hadid and Patrick works because it doesn't belong here, it doesn't belong to us. And at this moment, this is 2009, I think 2010, Zaha had a lecture in Egypt about her work, and it was packed. It was literally packed. So there was people were eager to hear. People wouldn't want to hear what's happening and how does these people work and how does these people develop these ideas and what kind of capabilities and way of thinking there is to reach for such a forum. And it's not just boldness. It's not just out of the blue. There was some standards and some structured way of thinking to reach for these designs. It's not just scribbles around. For me, this was the question: what kind of motives and how did they learn and drive through this? So I went back to studying my PhD, and of course studied with the source of all evils, better language for Christopher Alexander, that everyone and every lecture room has it in there. So Christopher Alexander basically started all this by telling us that it's a language. It has vocabulary and it has different sides of it. It has solids, it has voids, it has elements, it has towns, it has different scales. You can see it that way. It's not just a lump sum slum. No, it's just a series of elements that shapes people's experience. And this is something we have been told this in our classroom. All of us, most of us, have been told. If you studied in Egypt or any architecture school, you find someone mentioning a pattern language. You have to read it. You have to go through it. But nobody actually take you to the core, take you to the essence of what's pattern language and why would we need a pattern language for architecture or built environment. This was somewhere that I linked the work of Patrick and the work of the parametricism, as evil as it seems, into the world of action architecture. It's a pattern language. You can see it as a logic. So the speculations is a word that came out from Lila Marsh and Leslie Martin. Lila Marsh is someone that started to see architecture as the built forms and tried to find in his elementary models of built forms, he introduced this word, built forms, which were defined as mathematical and quasi-mathematical, meaning that it's not just mathematical. We are debating about the mathematics of how to transfer the geometry into computers or into mathematics first, and then computers or computer language. So basically, if you have a box and you need to move a point from through the walls of this box, you just unfold it to get it to mathematical, and then think about the distance and think about how the point is moving, and then translate that into mathematics, and then afterwards we can build on this to make it computational. And then Leslie Martin came up with the idea of urban as a grid of solids and void. The same grid can produce different aspects of urban, and it's not just a grid. It's urban. It's live. It's available and it's accessible. And at the same book, they talked about the speculations of performance. They talked about environment-related inquiries, again, mathematically. So after this, we see another word, shape grammar. What does that mean? It's like just to find the grammar for your shape. Your shape is not just there because you feel like it. It has to follow some sort of a logic. It has to follow some sort of a grammar. When you do this, it's an if-then kind of structure. So if you do that, you'll find this. If you do this, then this will lead to that. So this kind of development, of course, by Steiny, is also something to mention when it comes to the background or theoretical background of parametricism. It's not just the fancy and movie wavy buildings. It's something that needs to be taught and learned, and it's knowledge to be transferred. Then came up something like that. So a house is a machine for living in. That's Le Corbusier. And then the student is saying, but I thought that all the functional stuff had been refuted. Buildings aren't machines. That's a student. And then comes up Nick Dalton saying, you haven't understood. The building isn't the machine. Space is the machine. And of course, this is the intro for the space syntax book for Bill Hyler. Space syntax, also another word, is like, what's a syntax? What kind of vocabularies are you using? And how can you see your built environment into a syntax that it has commas and it has certain spaces and it has full stop? And what kind of translation of built environment into a syntax? We need to translate space into a series of syntax that we use to recreate that space. Someone else took it to the extreme, and now we have computers that works with geometry. Brilliant. Let's do more complex stuff. That's the work of Sudhu. That's the urban design of Sudhu, and he have plenty of options on his website that's called generative design. Generative. This is something new to our ears. Generative design. What does that mean? So we can generate shapes. We can generate built environment. We can generate buildings. That was, for me, this was new, and the limit he reached with its complexity, he actually aimed for complexity. He aimed to the extent and the limits of using and utilizing computational into his work. And you can see that it's like these for us, the people who have been taught Hassan Fathi and like the Al-Mu'izz and these kind of stuff, it was, oh, okay, this is urban. We need to look further. We need to zoom in. This is a bit pixelated, I know, but it's just, you can see that this is the extent of complexity when it's represented with computers. And I know that you're inner jangle with this photo won't work. It's like, no, 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 this will never work. Actually, just hear me out. So all in all, this has a background. This is not just a photo. This is not just a design. So I thought that this is, yeah, okay, this might be the other way and it might work. But then I was studying my PhD back then, and this I was building my literature review, and within that, I didn't find the aim. I didn't find the ending beam of light at the end of the tunnel. But when you just zoom out a bit, you will see that there is that this kind of debate between those guys and those guys is life, and it's still happening. And I don't think it will never end. I show you that from 70s till now, people are trying to computerize or digitize architecture, and there is people that actually against it 100%. And the way of debating that, for me, it was amusing to read, but it's a loophole. It's a rabbit hole again. It's just you go on and you'll never get out. You pick a side and be very, very aggressive. So I told you, I grew up, don't like this. I don't like this when I was growing up. I have been taught not to like it. And then now I understand it. I find it interesting. I don't have to like it, but it's interesting. But then this guy coming up and say he's a fascist, and he actually this was an article after he went out and said like the social housing should be abolished and we shouldn't have social housing schemes wherever. And people, of course, had demonstrations against his office or Zaha's office in London. So he's described as a fascist. Well, for me, it didn't matter that much after all. It was like, it's a debate. They, as we say in Egypt, أكل عيش. They are just breaking the bread. They are paying the rent with this, and this is how it goes. But actually, this building, this project itself, when you see it at its end product, this was 2009. And then in 2017, I found this publication that showed me it didn't still that fancy after all. It collided again with council measurements and the council requirements. And as you see, the blue, these blue buildings is actually, again, a Zaha product. And if you saw it, you wouldn't see that this is oh, Zaha did that. Oh, how Zaha office can get out with such a very cubic building or extruded building. They have to twist it or do something with it, but actually they didn't, because the council requested it that way. So this fancy project ended up, when it came to reality, again, it ended up colliding with reality and colliding with requirements and councils and governance and life and experience and blah, blah, blah. So again, so this raised the question, so where is reality? Where to go from this? Where to go out of this debate? Far in the corner, I found people looking into the ceiling and doing something called simulation and dealing with the buildings as if it creates an environment. So we see that buildings are actually our environment, and it's called the built environment, and it has a factor in when it comes to the performance and our comfort. So this was another door to knock on. So I studied a bit about the OGI and how buildings are actually is performing our interaction with environment. So it's one of our skin, it's one of our bubbles to control our environment and to reach for our comfort. And then what linked it to me was the work of Stedman. So Stedman, in his book Energy and Urban Built Environment, he broke down the built environment into elements and linked these elements into the performance aspect that it affects. So now we can see that this vague mirage of built environment can actually be turned on a series of parameters, and each parameter of those is affecting our performance and our comfort, our life and our experience in this built environment. This was, okay, this is something to recognize. So from this to this series, okay, this is something to work on. So from that, I saw parametricism differently, and I saw parametric design and computational methods really differently. It has a reason and it has an aim. This aim is to reach for people's comfort, for me at least. And this where it came with my PhD problem or statement problem or aim, how to utilize the state of the art, whatever computational there is, to reach for better performing urban. So I started testing buildings. I started simulating buildings, plenty of buildings, plenty of simulations and plenty of iterations, and to see what kind of performance aspects we're working with, what kind of performance aspect can be affected from the context in and from the inwards out. And for this simulation was my pilot study. Actually, I worked with energy efficiency, cooling and heating. We talk about lighting, if it's going to be dimming or is it on and off. We tested solar radiation or solar exposure for the middle building and how it's affected. And from that, we found out some stuff. The first thing, it's bad. It took time. It really costs life. It costs boldness and it costs gray hair. And these fancy tools are not as fancy as they seem to be. It's capable though. It can actually reach for hundreds and thousands and millions of iterations, but after all, it needs time and it needs computational force and it needs machines to run it. It's not easy. This was taken 2 a.m. at Cardiff Wilshire School of Architecture while I was doing my PhD. So it's not that easy to do. Simulation, maybe it's the answer, but it's not an affordable answer. It needs a lifetime to do it on an urban scale, especially. Another thing is that we can see urban as classified buildings. So each building has some sort of features that we can actually relate these buildings to each other and group them and classify them based on these features. And those two facts gave me the idea of my PhD, the method of my PhD. So I came up with a framework. It's still a proof of concept on how to predict performance instead of simulate performance for urban neighborhoods. So what's the scope of this framework? So we start with the model generation, and then we simulate some of the pool of iteration we create of this generation. So for example, if you have set your parameters to have a pool of 1,000 iteration, I would run 10 simulation instead of running the 1,000 to find the optimal solution. You will run just 10 of those or 100 or something. And then I classify that based on the pilot study I did. So to see what kind of features that affect the performance the most, and then classify the buildings based on these features. So when the PC finds out a similar feature, he can predict the simulation result without doing the simulation. So this saved the cost of time and the cost of computational force. So prediction was one of the methods I used. And then to find out the optimal solution, I applied optimization methods on that database and verified it, of course, from that database. But the optimization method was on the prediction. And from that, we find the optimal solution through this pool of iteration. So again, to make it simple, you have 1,000 options. To pick up the best one, you need to run them all, right? This is the normal thing. We call it brute force. But instead of doing that, you classify those 1,000 based on the buildings of each neighborhood. And then you do a prediction for each building and sum that up and find the optimized or the optimal solution by, again, another tool of computational methods. We'll talk about those in a minute. So I started doing the simulation. I started building up my classified database and doing the generation of this. So the model generation was basically to classify. I had developed this kind of classifying generation method. So it's not just generation and then classifying. So actually, when you generate, it's actually automatically classified. So we start up with, of course, a neighborhood like this, and then we classify the urban blocks. So once you classify the urban blocks, you classify to the center based on its orientation. And then I classify it against the exposure to the main street or not. And then within the block, we again classify for orientation for each building based again on the center line of each block. And then we create voids and placemaking. Now we're placemaking here. We create the voids in different ways. So either we don't have, or it's centric, or we scatter them randomly based on computer or based on user preference. And then we classify the buildings based on exposure to the main void, or the main piazza, or the main placemaking, or the main whatever you have. And then we create codes for each building based on a threshold of area. So if the building is larger than a certain area, we create a code for it or not. And then we introduce different ways of heights for each building. So we can have it based on attractors, or based on the user preference, or we can have it based on area, or we can have it randomly set based on a mathematical equation, again, for user preference. This end up with a very readable tag for each building. So we ran each building and created a tag or a name for each building of that. So based on these series of classifications. So for each building, we have the block orientation, we have the block exposure to the site, we have the building orientation within the block, we have the urban void, is it an urban void or not? And then we have how large is the area of it? Does it have a court or not? How many edges does it have as a topology? And what's the height of it? And then a series of comparisons of height for its surroundings. So we have a comparison for how many buildings are surrounding it, and how many is higher, how many is equal, how many is lower. And then we have another code to say which one is lower to which direction, and which one is higher to which direction, which one is higher equal to which direction, and so on and so forth for 360 of this exact building. And then another layer of that to find only higher or equal buildings on double the distance. So we have a very intimate proximity to the building, and then another circle of testing for the same building on its height. So to see if it's affected for each for this performance aspect, which was solar radiation, of course. So we created a database of these tags and these buildings simulated with results of solar radiation, blah blah, to train the PC on it. Train the PC on it, huh? This is something for me back then was train the PC. For this, I needed to introduce myself to this guy. This is Sir Alan Turing. If you don't know him, he had a paper called Intelligent Machinery. If you don't know the guy, you will know the movie. It's called The Imitation Game. If you didn't see it, it's about the same guy who actually deciphered the Nazis' code in World War II by detecting patterns. Basically, he found out someone sending love letters to his wife or partner, whatever, and he repeated a certain word for all the letters he used, and from that he could decipher the code for his letters, and from that they reached to decipher the whole code for Nazis during the war. And this is how Britain or UK or the Allies won the war. One of the reasons, of course, other than the nuclear weapon. But yeah, intelligent machinery. This term was also a bit old, but we now call it machine learning. And from that, he in the same paper talked about mimicking education. What's mimicking meaning? So we look into something and try to mimic it. We try to find some sort of way to mathematically adopt it into a PC. So that's basically mimicking. It has different applications, but today we're talking about artificial intelligence mimicking, or intelligent machine mimicking, whatever you name it. So mimicking education for him, to us, is machine learning, which means we basically teach machines how to think, or how to, not to think, but to predict, to find patterns, to find similarities. To know this is just a simple way of understanding how we think as human beings. So this is a neurocell, if you didn't see it before. Basically, what we need to know as architects about neurocells, that it has receptors. I don't know if you can see me drawing. I don't think you do. Yeah. So it has, no, it doesn't. Anyway. It doesn't show, but anyway, so it has receptors. Do you see my mouse? Amir, can you confirm that you see the mouse movement?
Yes, I see your mouse.
Okay. That's fair enough. So
Now I see.
neurocells has receptors finally thought out. So it has receptors and it has transmitters and it has the center of it. This is basically how neurocells are working, or how our brain is working. We have billions of this that thinks, that receives information, deal with it, and transmit it again. Can you please mute yourself, guys? Amir, can you make sure that everyone is mute?
Yeah, that's what I'm trying.
Okay.
Fadia
Anyway,
is not me.
let's continue. So we have neurocells, and we know how to what actually it consists of, and then this what creates our neural network that we have in our brains. This is basically how, or very, very lightly, how neurocells is working. So it receives information, tries to digest it in a way, sends it again, and then sends it again to another neurocell, which creates the neural system, which we translated into this, like having these nodes that receives information and then transmit it again. The only thing is, it's not just receiving and transmitting. It's actually vice versa. It goes and goes back. So it checks the variability and how right is it back with the previous node. This is a very simple neural network. It has only one layer, and an input layer and an output layer. This is actually an example from nature that actually they are predicting the average solar radiation for a building based on the weather. So they have the weather inputs for longitude, latitude, year, month. I'm sure most of you know this. But then instead of doing the simulation from the weather file, they do prediction, which is way faster. So we call this the hidden layer, and we call this the output layer, and we call this the input layer. And each node of those, again, is receiving from the whole input layer and then trying to predict what kind of result there is, and then checks back with the input layer, and then send again the refined result, and then checks back. We call this back propagation or gossiping. They gossip between each other, and then they feed on forward to the final output layer. So this is basically how machine learning can be working within the architectural unit. Then I applied this to my work. So you remember the tag, you remember the names. So we have the tag created a database. The final testing was a database of 200,000 training datasets. So I collected 200,000 and more, of course, from the simulation. And the neural network back then is two hidden layers. And the iterations, the gossiping, the back propagation between the nodes, it was 1,000. So before it goes forward, it can check backwards 1,000 times and then goes forward. That's as simple as we can describe it. The accuracy for it was really good. I didn't expect it to be that high, but apparently this was actually exceeded our expectations. It was almost linear. It's not that linear, but it's almost linear accuracy between the prediction and the simulation results. So horizontally, you will find the prediction. Vertically, you will find the simulation results. And the results there, it's almost a linear correlation. And that was, for me, this was enough to submit my PhD on this topic. And of course, it saved 97% of the time consumption when you do a brute force simulation, because we have millions of tags. We ran only 200,000, but we have literally thousands, millions of tags. But then when we did the prediction, we saved 97% of the time consumption. So this was the prediction bit. Then comes the optimization bit. So optimization, for those who don't know it, is just a selection method. What to find and how to find your best option. For this, I used a guard, not to allow the bad ones into the result. But actually, it's not. It's just called genetic algorithm. So genetic algorithm is again a biomimicry computational method that we can. It's derived from the evolutionary theory, And from that we claim that our genes are the better genes from our ancestors. So genetic algorithms is basically doing this. Imagine it's a guard on a pub or in a disco or whatever, on a party. It won't allow anyone under a certain age in. So that's what genetic algorithm does. So it's basically, you come to the party, you're not allowed. So it's just, it throws you away, and then allows who actually above the 18 or above 21, depends on the party you go, but to the room. So that's basically genetic algorithm. And then once you go out, it's just, there is another guard inside that actually allows you to the VIP, for example. And this guard needs a certain fitness, what we call for selection. It's just, it needs a certain criteria to let you in the VIP. So this is basically a series of guard, which is a genetic algorithm. It's a series of generation. You generate, and then you test, and then those who dies, and then those who live generates again. Those the parents for the new generation, and then the next guard test, and then see the fitness. Some dies, some live, generate, until you reach for the optimal solution. So that's as simple as I can for describing how genetic algorithms work. For my work, I had a pool of iterations of 23,000 and more urban neighborhoods from the parameters I mentioned before. For the last test, I ran only 100 iterations, sorry, and this created the fourth generation. So it ran 1, 2, 3, 4 generations with 10% crossover. So it will not allow more mating between the parameters rather than 10%. The results, it picked up the fifth optimal solution out of more than 23,000 iterations. So number 5 in the optimization, this is the fifth best option within this pool that achieves the solar radiation and achieves, for me, the floor area ratio, which was the other aspects of optimization. So I was enlarging the floor area ratio, and I was decreasing the solar radiation for the whole neighborhood, of course. Again, this was based on the prediction. Fifth optimal solution, and it was 6% of the brute force. So if I ran the 23 more iterations, it will cost me, I don't know, 94% more of time. So this was 6% of the time of the brute force for the whole pool, of course. So this was, again, something to think about, that, okay, I have good results, I can submit, but then there was always that one more thing. So the one more thing in my case was to have actually a case study of a real building, of a real neighborhood, of something existing. All of this was just generated from my tools. So how about I test this framework against something real, against something existing? So my case study was in Aswan, and for me it was Aswan الجديدة, New Aswan, because I had some information about it and how they were designing it. And of course, it's designed as every other new city or every other urban community generally, not just in Egypt, that we go and we do streets and we just design, not for people, but we design. Then I did the analysis. I just collected the data from هيئة التخطيط العمراني, the ministry, from the Ministry of Housing, and those who actually take care of this.
General Organization for Physical Planning, GOPP.
Thank you. General Organization of Physical Planning in Egypt. So yeah, and then selected a neighborhood in there. Tried to speculate the heights from Google Earth because most of it is built already. Did the model in 3D. Did the analysis for solar radiation. And then the results that I reached is optimal to the solar radiation of the existing building using the tool. So those are the two optimal solutions out of running the whole framework on the existing and the exact boundary of the site. And it ran almost for 6 hours or something and gave me those two results with the same and better floor area ratio and better solar radiation exposure, meaning less solar radiation exposure for those buildings, meaning that these buildings are consuming less energy, better for economy, and etc. etc. You know the game. So after that, I'm thinking of testing. We have a swan here, so I'm thinking of testing that, and actually do test that to the approximate weathers. So would it work? So this was hot arid zone. So would this work for hot zones and hot humid zones? And then the pilot study I did was also in London. It wasn't only Aswan, but I didn't have the time to do the same framework and the same testing for London too. So we killed London and we continued with Aswan. But this is also another test to do the same for London. And hopefully we collect some data for other regions. And we can sometime maybe depend on these for the early stage of design of urban neighborhoods everywhere that actually can inform cities for people and can inform neighborhoods for people. And it's not just drawing lines, and it's not just going into slums after it's built. Actually, in the early stage of design, you can actually adapt and you can actually find some performance-based solutions very fast and very quick. So at the end, it is cities for people, 100%. But we need to think how we are designing these cities for people. We need to think for what aim are we designing these cities for people? And what are the tools that we have become available now for designing these cities for people? And finally, I would like to thank you all for your attendance. And thank you for attention. Thank you so much.
Thank you very much, Anas, for a very interesting lecture. I think now we can open the floor for discussion. So if you want to use your Zoom hand and raise your hand for a question. I have like 100 questions, but I'll leave them at the end. So let me
leave this on just in case.
Okay.
I need to see you guys. I don't know how to see you.
عشان أنا الهوست ما ينفعش عندي ريز هاند، أنا من الوحيدة اللي محرومة من الهاند، بس ممكن أسأل؟
Yes, please go ahead.
أول حاجة عايز يعني أشكرك جدا جدا يا أنس إن أنت منورنا النهاردة في قعدة القهوة، ودي كانت محتاجة قهوة فعلا. الحمد لله إن أنا جبتها. مختلفة تماما الحقيقة عن مجال تخصصي أنا الشخصي. والنهارده انا شايفه يعني لازم ارحب برضو معانا النهارده ضيوف كتير جدا جداد، يعني دي اول مره ينورونا واحنا سعداء جدا بوجودهم، ويا رب يكون وجود دائم معانا ان شاء الله. فالمجال اللي انت بتتكلم فيه الحقيقه نقول تخصص دقيق جدا، اورينتد اكتر على البيلدينج بيرفورمانس. فانا عندي الحقيقه دايما نفس التساؤل، هل وانت بتشتغل على البيلدينج بيرفورمانس والمفروض ان ده بيحقق احسن اداء للمباني من الداخل، يعني برضو بنتكلم على بشر ومستخدمين، هل بيكون الفاكتور بتاع البابليك سبيسز او لو بنتكلم على solid void يبقى هل الكلام على الفويد within the city fabric بيتاخد في الكونسيدريشن بتاعك وبيتراعى؟ يعني هل بيكون من ضمن الكرايتيريا بتاعه الايفالويشن ولا ده بيبقى the leftovers from the buildings؟ ده السؤال بتاعي.
Okay, should I answer in Arabic? Should I answer in English?
I think
احنا معانا حد من الضيوف مش بيتكلم عربي؟
answer العربي خلاص.
هل معانا اي حد من الضيوف؟
هو اكيد مش هيرد على السؤال ده.
الفكره ان هو احنا بنصمم العمران ازاي؟ انت بتصممي العمران الفويد الاول ولا السوليد الاول ببساطه؟ فهو احنا بنصمم السوليد والفويد معاه، مفيش حاجه اسمها it's a left over. Again, this is the idea of the debate. احنا بنتخانق مع بعض اللي هو ايه ده انت مش واخد بالك؟ لا هو انا واخد بالي على فكره، انا مصممه والله، بس هو الفكره ان هو it's a main factor when it comes to performance. Voids and spaces is the main factor when it comes to performance. Of course it's a factor, but it's not just about how people are going to sit there. And actually when you design, يعني أنا آسف لما بتصمم وأنت رايح تصمم عشان الناس تقعد, you have to think about their thermal comfort. هيقعدوا قد إيه؟ وهيطولوا لحد امتى؟ وانت عايزهم يطولوا لحد امتى؟ انت عايز تضايقهم وتمشيهم ولا عايزهم يقعدوا؟ ده مين هيقرر الكلام ده؟ هتقف توقف واحد يقول لهم عايز حاجه يا فندم زي ما بيحصل عندنا، ولا هتصمم المكان بحيث ان هو يبقى مرحب لفتره معينه؟ مين اللي هيديك القدره دي؟ غير النيتشر، غير الانفايرمنت اللي انت بتصممه. فهو مفيش حد عنده القدره ان هو يكنترول people's behavior more than nature itself. We claim ان احنا بناخد بالنا من الناس و their behavior وبتاع, بس هو الحقيقه we're totally neglecting the performance of their thermal comfort and the built environment in general, just based on and we neglecting. I can actually pull up the other side of the debate, that you're just thinking social, but think quantitative again. What kind of other aspects that control the people? It might be that they cannot afford to sit out. They don't have enough clothes, maybe. That's from your side. From my side, the sitting is in the sun. It doesn't have enough shade. So it gives them the shade, they might sit out. So هي بالبساطة دي ممكن هو انك تشوفيها left over. That's an extreme. It's never left over. Actually, one of the aspects there في الفريمورك ان احنا بنgenerate different ways of generating urban voids or piazzas, or I'm sorry to call it voids, but this is how I treat things. But هي voids solids. فاحنا في طرق كتيره جدا نقدر نكريت بيها voids, منها ان انت كديزاينر to select the places for your voids and يعني ممكن تحطهم جنب البيوت اللي هي السوشيال وتسيب او السوشيال هاوسنج وتسيب الناس الاغنياء في جناينهم براحتك. انت صممها زي ما انت عايز, بس انا شغلتي ان انا اقول لك ده هيبرفورم ازاي وده هيبرفورم ازاي, وانت تختار انه واحد اللي هيوفر للناس عيشه افضل واكسبيرينس افضل based on performance. دي كل الفكره.
انا استاذن بس امير ثانيه واحده. يعني انا يمكن انا فاتني ده, بس انت اللي انا اخدت بالي منه انك اتكلمت على البيلدينج برفورمانس, فمعنى ردك ان انت كمان بتقيس السبيس برفورمانس.
طبعا
الفويس برفورمانس.
ايوه احنا الاسبكت ده اسمه سول راديشن. سول راديشن اللي هو قد ايه من المبنى بيتعرض للشمس. احنا لو احنا قلنا ان دوت حاجه بيلدينج بس هنبقى غلطانين, لان هو في الاخر هو لازم هيتاثر بالفويد بتاع الاربن اللي انت موجود فيه. ده واحد من الاسبكتس اللي انا شغال عليها ان هو الاوت دور ثيرمال كومفورت. ان احنا الناس اللي قاعده بره اخبارها ايه؟ يعني هم انت بره اخبارك ايه؟
بالظبط هي دي النقطه المهمه اللي كنت بتكلم عليها.
مريح بالنسبه لك ولا انت نجيب لك حد يقعد معاك ولا ايه النظام؟
فهي بالذات في المناطق اللي انت اخترتها as a case study for your application, هي دي فعلا الناس لازم تكون عندها thermal comfort, otherwise هتتحمص. يعني مش هيبقى في مجال انها اصلا تتعامل مع الحراره.
يعني هتتحمس او هتبقى متضايقه طول الوقت من المطر والمشاكل وبتاع. فيعني
شكرا جزيلا يا انس. شكرا على التواجد.
شكرا انس. السؤال الثاني دكتور بكر عليا. دكتور بكر رفع ايده صح؟ دكتور بكر احنا تقابلنا قبل كده؟
مش فاكر.
North Dakota? Are you based in North Dakota?
North Dakota, yeah. I'm in North Dakota, yeah. In the cold.
Yes.
We are freezing here.
Yes, تقابلنا on campus. I think.
You applied one time, yeah.
Yes, أنا افتكرت الأوفيس بتاعك.
Yeah.
Okay, فرصة سعيدة جدا.
أنا هفتكر هو ده أوفيس ما يتنسيش.
Yeah.
Okay.
That's right. I mean, yeah.
Go ahead.
So I would like to thank Amer Johar for his wonderful presentation and Dr. Lobna Abdulaziz. And I would like to record this kind of introduction to what's Arabic placemaking organization, and record that and put it in your website, because it's a wonderful introduction and puts a map and who you are and all that stuff. And thanks so much for Anas for his wonderful presentation. Start from, I think he started using the digital to study sustainability, which is a good concept, connecting how we can make this simulation to understand the aspect of sustainability integration in a visual contact. That's great. And the lead and all these green organization you talked about, and then you bring Professor Jangel from the Danish. He's a great guy. I use him in my lecture because I teach sustainability University seminar for graduate students. And he's a wonderful example, especially the 18 minutes presentation that Dr. Al-Kholi posted in his website. It's a wonderful thing to see how the Danish people doing in Copenhagen. I presented one building, it's like a factory, how they turn a factory for recycling material into a wonderful, wonderful attraction to public people to come in and they enjoy the roof of the buildings, the green roof of the building, and they make this like a slide, like, you know, I do have a slide, I can show it about this building. You don't have the sharing. But yeah, that's a great thing to mention, Janjit. Do you have a sharing?
Open
the sharing.
Lobna is the one who can open the sharing or make you a co-host.
اتفضل دكتور بكر، تقدر تعمل شير من عند حضرتك.
Yeah, if you can see that, yeah, so that is the example. I would like just to bring that example. This is Sustainability of Love, Alexandria Library, but there's Zahdid in Chicago, but there is a building in Copenhagen. That's what I want to bring. Let me.
Do you want to email it later? أو مش later?
I can, yeah. It's kind of like a great example of this sustainability. I would like just to bring it to everyone's attention, how we can turn an ugly place into a really wonderful.
Why don't you email it to me and I'll email it to the mailing list? Are you part of our mailing list?
Yeah, sure.
Yeah, okay. So you can please.
Yeah, and then you bring the Alex example, which is you mentioned 70% of our building in Egypt is slum areas. So we need to think about it. There's a lot of you mentioned about the Patrick and the world of pattern. That's a great thing. You mentioned something about the architecture form and the mass to compile the language of the architecture and the grammar and the logic, and the house is a machine turned to be a space is a machine. And then it came to my question to the parametric design, because parametric design is very similar to the tool. Because I remember in 1996, I used Visio as similar tool, how to animate some kind of conditions and use a Visio to make the conditions and how the solution of optimization of a solution to bring this to the decision maker to say, okay, we do that. So it's a wonderful thing to say that we can use this kind of competition or computer or animation to bring solution. My question for this, because there is a lot of information that you mentioned about the success of the study and 97% reduce, and you take the Aswan as a new city. My question about using parametric design as a tool or your tool as a very kind of a creative solution, innovative solution, how we can use that to solve the problem of the 70% of our slum areas. How we take this, I can call simulation is maframa. The simulation is a maframa. How we can take this 70% of our slum areas and put it in the maframa of simulation to see, take this off and put this on and make this kind of a very beautiful, as the Brazilian did. The Brazilians actually did this, and Argentina is doing the same thing. Take the slum areas, tend to be a beautiful solution.
Anas, the question, and there are so many other questions and comments. So just to answer the part of how to broaden this to apply it on the 70% informal urbanism to be able to pick which stays and which goes.
Okay. It's not about picking which stays and which goes. Dr. Bakr, do you mind if I will speak between Arabic and English just for everyone else? But the idea of it is it's data, okay? It's not about simulation, it's about optimization. So we're talking about data. If we have the data for these slums, if we have the access for data for the existing slums that is available, Aswan, the new Aswan case study is actually a bit up. It's already an existing neighborhood. When it comes to slums, I have participated in some work with a Brazilian friend for studying balconies, for example, with doing parametric simulation and optimization for balcony shapes. So the photo I showed about the curtains in the narrow street, we can easily do a simulation of that and see which is for privacy and which of reducing sun exposure. We can actually deal with data as whatever we want to. It's just a series of data. Even human behavior in that case, we can boil it down. I know some of the guys here, I can see some aggressive questions. It's about data. We deal with data. So slums is a series of performance data, and we can enhance it by applying optimization for these kind of performance. That's it. That's the simple question. That's the simple answer for your question. I hope this is a proper answer. But yes,
okay. Thank you so much. Now I'd like to take a comment from Dr. Foley. Dr. Ahmed.
Thank you, Dr. Amir. Thank you, Dr. Anas. Congratulations for your Akhiran, finally, alhamdulillah. I just want to make some points. Let me start first with about the slums, and I'm gonna, I mean, you have raised some nostalgic feelings for myself at the moment, because the term slums, it's not the accurate word for what you have presented.
I know.
It is better, some would say informal, and I would say spontaneous, because that's what people do. That's what birds, how they build their nests. That's part of being a creature created by the Lord. So what you have assessed in Aswan is not something created by the Lord, but rather, I would say, by Satan, which I think I'm really astonished to find that they are energy efficient. I've been to such similar projects where it was better to be outside the building than rather be inside the building. That's one point. My other point is about the word sustainability, and I really see it abused, because it's a multi-dimensional concept. Unfortunately, it is a concept that is very naive and in itself conceptually contains a lot of